Hi folks, welcome back to the 6.3 practice. We're going to take a look at question number 1 again from a different lens. Okay, so same question we saw in video number 1. We know what our answer is, 9 pi over 2, but this time we're going to take a look at it using shell method. Okay, so let's start with a diagram, okay, and the first part of the diagram is going to be very similar. So I'm going to draw the orange curve, the blue curve, and then the red reflection. So my orange curve, my blue curve, and I sealed it off with the pink line. All right. Okay, so that's my region. I'm still revolving it around the same axis of revolution. So that x-axis is still my axis of revolution, which means that my reflection should look the same. All right, so this time what's going to be different for us is that we're going to set it up differently, okay? So we still have a shape where we have this hole in the middle, okay? And what we're going to do is we're going to think about what it means to set up shell method. So with shell method, what we do is we draw our lines parallel to our axis of revolution. So in the first diagram, you can see that those green lines are perpendicular to the yellow line. But now I'm going to draw some pink lines that are parallel to the yellow line. So for example, I might have a line like this. Okay? Now that pink line is parallel to the yellow line. But here's what that represents, okay? That line and its reflection down here are the height of the shell or the cylinder. Okay, so remember, a shell is a cylinder, not like a seashell, but like a toilet paper roll. So if I were to sketch in the shell, I would have one kind of like that. Whoa, not what I wanted. So let me try that again. Okay, and then over here. So we've sort of made it three-dimensional for ourselves. All right, that is one example shell. Now what I can tell by that is that my shells sort of expand up or out. That means that I'm going to be using dy because these heights of the shell are being stacked up the y-axis. All right, so let me set up my formula here. Volume equals not pi r squared, but 2 pi, the integral from c to d of radius times height dy. Okay, now that's my general formula, and now my job is to figure out my c, my d, my r, and my h. So my c and d need to be y values. So let me go back in here and label this point. So this point was 1, 1, and this point is 4, 2. And last time when we were doing washer method, we chose the x values. But because our shell method is indicating to us that we need dy, we're going to choose the y values for our bounds. That means that I can go ahead and write in 2 pi, the integral from 1 to 2. Okay? Now we need to figure out the radius. Now for our cases, we're going to stay relatively simple, and we'll always have our axis of revolution as the y-axis or the x-axis. So in those cases, what we can say is that the radius, okay, the radius is going to be whatever letter is at the end. Okay, so in this case, my radius is going to be y. And that's because I'm stacking them up the y-axis. Now the height of the shell is going to depend on if we have a right curve minus a left curve. Okay, so this brings us back to when we learned about area. So I want to think about the curve that is to the right of this pink line. And that is just this line right here, which is 4. And then the curve that is to the left of this line is the orange one, which we can call square root of x. Okay? Now, some of you might feel really uncomfortable because I have everything in terms of y except for one pesky function. And so I need to rename that one so that everything is in the same letter. And so let's do that up here. If y equals the square root of x, then that means that when I square both sides, I get x equals y squared. And so y squared is what we're going to put in for the square root of x. That will give us 2 pi, the integral from 1 to 2 of y times 4 minus y squared dy. And we're going to go ahead and distribute this y, so we'll get 2 pi, the integral from 1 to 2 of 4y minus y cubed dy. And now we're going to take our integral. So we get 2y squared minus 1/4 y to the 4th, and I'm going to plug in 2, and I'm going to plug in 1. All right, let's plug in our bounds. So I've got 2 pi all the way on the outside, and then I have 2 times 2 squared minus 1/4 times 2 to the 4th, minus 2 times 1 squared minus 1/4 times 1 to the 4th. Now let's see what that simplifies to. We've got 2 pi. I've got 8 minus 16 over 4 minus 2 plus 1/4, which equals 2 pi times 6 minus 15 over 4, which gives me 2 pi times 9 pi over 4, which gives me, or sorry, not 9 pi, just 9, which gives me, let's see, these two reduce, and so I get 9 pi over 2. Now, if I take a look back at what I did using Washer method, I will notice that these two answers are the same, and that's really good, because if we're taking the same shape and we're revolving it around the same axis, we should get the same answer. Okay? So, that's where we're going to stop for question number 1. When we come back in video number 3, we'll take a look at a new question, and we'll look at it at both Washer method and Shell method. All right, see you there.